Welcome friends to JCE Connect. Today's module is 5.2. Myself Dr. Anand Kevasmani, Jain College of Engineering, Belagavi. Let us see the outline presentation, that is first one is introduction, manufacturing, types of manufacturing system, the production system, machine tool, conventional machines, manufacturing support system. Let us see the introduction. Manufacturing is a branch of industry, is the application of tools and process for the transformation of raw material into finished product. Manufacturing sector is closely connected with engineering and industrial design. Manufacturing includes all intermediate processes required for the production and integration of the product's component. The term manufacturing system refers to the collection or arrangement of operations and process used to make a desired product or a component. In manufacturing system, if there is a change or disturbance in the system should accommodate or adjust itself and continue to function efficiently. Let us see the manufacturing. Okay, when the word first appeared in the English language around 1567, by seeing the picture that I have discussed about defined simply the manufacturing. Manufacturing can be divided into two things, that is manners and factors. Manners means handmade. Here you can observe this person is making the wooden part by using a hand, and factors means made. Handmade goods and articles is known as manufacturing. Let us see the types of manufacturing system. In types of manufacturing system, we have continuous flow process, mass production of discrete products, batch production, and job shop production. Continuous flow process. Okay, let us see the continuous flow process. Flows process for beginning to end, here said, or the continuous dedicated production of large amount of bulk product. Continuous manufacturing is represented by chemical, plastics, petroleum and food industries. We have seen that is sensor technology available to measure the important process variables, use of sophisticated control and optimization strategy, full computer automated lines. Whatever I given in this slide, this is the achievements in continuous flow processes. Let us see the mass production of discrete product. Mass production of discrete product, dedicated production of large quantities of one product with limited model variants. Example, it includes automobiles, appliances like fridge, refrigerator, washing machine, cooler. Okay, these all are the example in case of this mass production discrete product. And these are the achievement, that is automated transfer machines, dial indexing machines, partial and full automated assembly lines, industrial robots for spot welding, part handling, machine loading, spray painting, automated materials handling systems, computer production and monitoring. Batch production. Batch production we have, that is production of medium lot size of the same product. Production of medium lot size of same product. The lot may be produced once or repeated periodically. Okay, we can have the example, that is t-shirts, manufacturing of books, and what all achievement we have achieved in case of this batch production are, that is numerical control, direct numerical control, that is DNC, computer numerical control, that is CNC, adaptive control machining, robots for arc welding, parts handling, etc. And computer integrated manufacturing system. As I shown some batch production before, that is in textile industries, that is in case of this t-shirts, and I have shown that manufacturing of the books in paper industries. These all whatever are in the slides, these are the achievement. We have, that is job shop production. In case of this job shop production of low quantities, often one kind of specialized products. The products are often customized and technologically complex. The example is an aeroplane, or here the achievement in job shop production is numerical control, computer numerical control. We have, that is the production system. In production system we are going to have, that is manufacturing support system and facilities, that is here, that is factory equipment. They have interconnection between manufacturing and the facilities with respect to the factory equipment. We'll see the production system facility. What are the production system facility? Facility include the factory, production machines and tooling, material handling equipment, inspection equipment and computer system that control the manufacturing operations. We have, that is plant layout. Plant layout means the way the equipment is physically arranged in the factory. Manufacturing system, logical grouping of equipment and workers in the factory production line. We have stand, that is alone workstation and workers. We have the manufacturing support system. In case of manufacturing support system, we have business function. In business function we are going to have sales and marketing, order entry, cost accounting, customer billing. Second, we have, that is a product design. In case of product design, that is research and development, design engineering, prototype shop. We are going to have manufacturing planning, that is process planning, production planning, MRP, capacity planning. In manufacturing control, we are going to have shop floor control, inventory control, quality control. Manufacturing support system, we are as we have seen in the previous lecture about this, that we are going to have, that is customer order. Then after getting the customer order, we are going to prepare the product design. After getting prepared the product design, we are going to manufacturing planning, and after manufacturing planning we are going to do manufacturing control. Then we have business function, as we have seen this business functions, manufacturing planning in the previous slides. We'll see what is machine tool. The main function of machine tool is to remove metal from a piece of work to give the required shape and size. This is accomplished by achieving proper relative motion between workpiece and the tool. That we can take the simple example as a lathe, milling, drilling. These are the example of machine tool, where to get a required shape and size, there is a function of machine tool for the removal of the metal from the piece of the work to give the required shape and size. That is, there is relative motion between the tool and the workpiece, and the tool should always harder than that of the workpiece. Then the chip start moving ahead of the tool. We have that is conventional machines. In conventional we have that is lathe. The job is fixed between the centers and made to rotate by powering the spindle. That is, the tool motion is achieved by operating the hand wheels and the feed rates are manually controlled. Conventional machines. The productivity and quality of the product depends on the operator skill and attitude. These machines are characterized by low speed, feed and metal removal rate. Producing complex part will be difficult. That is a simple example. This is, here we are going to have that is tool post, we are going to have carriage, we are going to have the different parts we are going to have, in which here we are going to have that is, in a chuck we are going to hold the job, and here the tool post we are going to fix the single point cutting tool, and then we start that is the there is a motion, that is the tool is going to start remove the material from the workpiece, then the chip moves ahead of the tool and the material removal is going to takes place to get a required shape and size. And in today's industry requirement, we are going to have that is main requirement of machining industry is that the machine tool must be flexible, suitable for batch production and capable of carrying out many operations on the single setting, and high metal removal rate is going to takes place. And in if you see the history, then we'll that in 1947 that is John Pearson and US Air Force defined need to develop a machine tool capable of machining complex and close tolerance aircraft parts with the same quality time after time. And in 1952 this MIT is the subcontractor and builds the machine for the project. And in 1959 MIT announces automatic programmed tools, that is APT programming language. And in 1960 we are going to have that is direct numerical control, that is DNC. This eliminates paper tape punch programs and allows programmer to send files directly to the machine tool. And in 1968 Tracker Machine Tool Builders market first machining center. And in 1970 CNC machine tools and distributed numerical control come to the picture. And in 1980s graphic based CAM system introduced, Unix and PC based system available. And in 1990s price drop in CNC technology has taken place, and in 1997 PC Windows based open modular architecture control, that is OMAC system introduced to replace firmware controllers. And if we see that NC machine, in NC machine we are going to have that is NC, that is numerical control machine, also known as NC machine, is an automated machine in which the machine tool control is programmed with a series of numbers, letters or symbols and initiated in the electronic controlled system. This number represents the tool position, cutting speed, feed, etc. If we see, the concept of NC was proposed in the late 1940s by John Pearson, who recommended a method of automatic machine control that would guide milling cutter to produce a curvilinear motions in order to generate smooth profiles on the workpiece. And the advantage of NC system we'll discuss in the next class. Thank you for watching.